invite George to. Okay, the meeting is being recorded. You'll be able to share the recording at the end of the meeting. And then, so now I'd like to invite George to go ahead and take you through today's session. George.
Okay, good evening, everyone.
Good evening.
Hope I'm audible. You can hear me from the other end. Okay, that one being said, so I'll introduce myself. I'm George Okoth, Head of GIS and Remote Sensing at Oka Services. And today I have the pleasure to take us through image processing using ERDAS Imagine. So shortly I'll be sharing my screen. So hopefully you can see my screen.
Yes, George, you can see your screen.
Yes. Sorry. Let me just exit first. I started from the beginning. Now, being students of remote sensing, I know these terms like image processing is something that is familiar to you. Basically, preprocessing are those procedures that are undertaken to help in either restoring the image or making it better for subsequent interpretation and analysis. Now, basically, procedures include radiometric correction, geometric correction, terrain correction, enhancement techniques, and some feature selection. And the aim of doing all these procedures is to increase interpretability of the image and also to improve classification accuracy. So image process is actually a prerequisite to image classification and change detection. So basically, we have divided this thing into presentation and some demo. So image rectification, as the name suggests, is simply tries to help to fit your image to please mute yourselves. Okay, so as I was saying, image rectification is basically to kind of help your image to fit into a map projection or a reference image. Basically, there are two ways of doing it. One, you could have already rectified image, and the other one is unrectified image, or you could have control points that have been obtained through control surveys. So generally, it involves the following step. In ERDAS Imagine, you need to display the two images, one that is to be rectified and rectified image, and the other one being a reference image, which is already kind of rectified image. So once you do that, there is a tool called geometric correction tool. And that geometric control tool, once you open it, you are able to pick control points. And the control points that will pick, the software is able to compute a transformation matrix, which basically links points from the unrectified image and rectified image. Then you state a resample procedure, basically either using linear or bilinear, those algorithms. And finally, once you run the process, you need to verify whether this process is success or not by basically evaluating the process. Okay, there is also this thing called atmospheric correction. Also, this one is a procedure that is applied to just basically to increase accuracy of image classification. As you know, during image collection, there are basically some effects of either clouds, haze, or some conditions that may interfere with interpretation of the image. Therefore, atmospheric correction is applied to basically able to restore the image to eliminate the effects of atmosphere. Excuse me, please unmute your... Hello, participants. I'll kindly request that you unmute mute yourself.
You can continue, George. I have already muted the person who was making noise.
Okay, thank you.
Okay.
Then, so basically, I was saying that atmospheric correction is basically done to remove the effect of haze, clouds, and the rest. Usually, this one, once you do that, you are able to increase accuracy of image classification and also to minimize the effect of haze and those illumination effects. Then there is also what we call destripping and line drop removal. As you know, Lancer 7 suffered some defects. In ERDAS Imagine, you are able to replace these bad lines. Basically, this generally to remove the noise in the image. You are able to replace the stripping or the bad lines so that when you do the classification, at least you have something that is comparable, especially if you're doing change detection. Then there is what we call salt and pepper. So salt and pepper is basically a noise in an image. It is usually very unpleasant. It can be bad for analysis, and basically we need to denoise. So in ERDAS Imagine, there are inbuilt filters that are able to eliminate this kind of noise. We have what we call image stretching. As you know, basically images are just stored in digital numbers that ranges from 0 to 256, which is 256 grayscale level. You find out that default display of image sometimes does not render it well. So image stretching is basically to enable you to adjust some kind of brightness and contrast so that the image appears more better, visually better, and you can be able to interpret features of interest from it. So this is the kind of filters that I was talking of. We have what we call high pass filters and low pass filters, and they have different uses. So high pass filters are mainly meant to emphasize edges or linear features. So if you have what we call, you have heard of edge enhancement. Basically, it's just to emphasize the detailed high frequency component, especially where there is a linear feature or could be a edge. Then there is a low pass filter, basically is to remove noise or basically to smoothen an image. And it's mostly commonly used after full classification. You have heard of majority analysis. Basically, that is a filter to remove salt and pepper. So basically, so that you have features that are pronounced and it sieves out features that are isolated. There is also what we call image stacking and compositing. As you know, satellite images comes in a number of bands, and these numbers of bands, they need to be put together so that you can be able to display them in a number of ways, what we call compositing. Now, stacking simply means that you bring two or more registered images together. Usually, the idea is that when you are doing classification, you are doing it to several bands. So you have heard of standard color, you have heard of natural color, standard color, false color, composite, and the rest pseudo color. So those ones are brought about as a result of stacking images together and displaying them in a number of combinations. Then there is what we call subsetting. Okay, sometimes you can have a good example is Landsat. You can have an imagery that covers a very big area, and you are not interested in the entire scene. You could be just interested in a small portion of that scene, and therefore you need to just extract the area of interest. That one is what is in ERDAS imaging is called subsetting. In other software, they could be called clipping or submapping, depending on the literature of the software. But basically, the main idea is the same, just extracting your image to the area of interest. And once you do that, you can be able to, you can able to just work within your area of interest. It makes features more obvious. It improves image enhancing. You can do extract features like do image classification from your area of interest. Then finally, there is what we call mosaicing. Mosaicing is simply means piecing together images side by side, especially if the images are overlapping. So you could have an area of interest that is bigger than one scene of that image. So therefore, if you want to do your analysis, it will require you to piece together all those scenes that cover your area of interest into one file. That is what we call mosaicing. So that's, I'll stop there for the presentation and now get back to what we call the practical. So in the practical session, I'm just going to show you a sample of image processing technique, and I'm going to use image rectification. So just give me a second so that I can launch my ERDAS Imagine. Okay, I'll share my screen. Basically, this is what we call ERDAS Imagine interface. I'm currently using ERDAS Imagine 2022. And I'm going to show how we do image rectification. Now, first thing first, in ERDAS Imagine, it's usually recommended that we set the preference before we do any other thing. So we come to File, then to Preferences. Now, there is something called a Preference Editor. basically it helps you to define where your data is stored and where you will keep your outputs. Now, what I'm going to do is this. Usually there is a pen here, something that looks like a pen here that you need to default data directory. You click on it, then you navigate. You navigate to where your data is. For my case, it's in D. Then I called it image. I called it image rectification. So you ensure that you have it, you click it until you can see the inside the folder. Then also you need to set the default output directory. For in this case, I click on it, then come to image rectification folder. Then I need to define a folder called output. So I just click on this, then call it output. Now, the reason I'm doing this one will save you time if you want to navigate to where your data is. So I'll just save, then close. It should be fast. Now, then the next thing, among the procedure I said, you need to display the two images. So in ERDAS Imagine, to display image, you simply right-click on the 2D viewer. Sorry, let me just open the... So I'll open a raster layer. First of all, I'll open unrectified. Unrectified image is called TM image. Now, it's a multi-band, it's a multispectral image, but for this lesson, for this time around, I'm going to open it as a single layer, as a panchromatic. So I come to raster option, then open it as grayscale. Then I'll pick one band, which is 2. So this is it. It's now displayed as a grayscale. I'll open another image, which is of the same area, but is rectified. To do that, I need to open another view. So I'll just come to Home, add views, then display 2 views. So on the second viewer, I will add a panchromatic band, a panchromatic image that is already rectified. So I again open raster layer, then open this pan image. So as the name suggests, it's a panchromatic image. So we have these 2 images. I can fit this one to frame, and I can fit this one to frame 2. So basically you can see features that are common. For our case, for the sake of this exercise, I'm going to show you the common area of interest. So one will be here. In most cases, when you are picking your ground control points, you basically look at places with road intersections, rock outcrops, and maybe a corner of house, if you can clearly see in the image. But yeah, so we will pick this point. We'll pick another point here. Then we will also pick another point So I'm basically going to show you where we are picking points from. So let me show you in the panchromatic. So we pick somewhere here. We pick somewhere in the bend here, in this road bend. Then we also pick another one in these sections. So that one said, after doing that, you need to open geometric correction tool. So where do you get it? Where do you get the geometric correction tool? You need to just go to this panchromatic tab. Then while you are still active on the viewer 1, which contains an rectified image, you just need to go to control points. Now it will bring you a window called set geometric model. So leave it that, then you just scroll down to polynomial, sorry. Once you pick a polynomial, you just say okay. So it will bring you this multi-point geometric correction. So you will leave it default for the image layer, new viewer. Then for the reference image is basically the image that has been rectified. For this case, is panchromatic image, which is pan image. Now, we'll just say okay to this. Then you close. So we can see in the multi-point generation geometric correction window, we have reference image and rectified image displayed. So basically what we need to do is to establish the common points. So we pick like ground control points on both unrectified image and rectified image. So watch me now do it. So the first point that we are going to incorporate in this exercise is this. You are just going to pick this intersection here. Like in this case, this is where they intersect. You zoom until you see the pixels where the intersection is. Then you pick the create GCP. You click on it and click on the same point on the rectified image. So in this case, I also pick at the intersection. Now, so it's also good to, because you see by default, the control points are white in color. You can change them into a color that can be able to distinguish them well. So you click on this lower window, which is, let me just zoom it so that you can clearly see it. So there is a lower window there that basically is a table that show you the link between the unrectified image and rectified image. So when you click on this, you are able to change the color. So just change the color. You can change color here. You can also change the color of reference to yellow. Okay, so we have basically inserted for one control point. The next thing that we're going to do is to identify the second point. So the second point is somewhere here, this bend, so you zoom, usually you can zoom out to full extent, then locate where it is. Then for my case, it's this bend. So I'll click on it here. Then also click on the same area. So in this case, this one is right here. So I'll also pick the bend here. So where the bend is. Notice that you can always move this, you can always move the GCP to fit into exactly where it is. Now, again, I can change the second set of GCP to a different color. So for the first one, I can put yellow. Then this one, I can put magenta. Again, I will check the third control point, basically in this bend. Notice that I'm picking these bends. So in this case, I'll just pick this junction here, where the corner here. So I click on it. I also do the same for the from the unrectified image. So in this case, this is it, somewhere here. Again, I change the third to chart another color, like purple. Then finally, I'll need to get the fourth one. So the fourth one, I'm going to take this one, this somewhere that looks round like this place. So I'm going to click on the center, the same. So you realize that when you pick the fourth point, basically it's able to show you where it is. But you can, if you feel that it's not exactly where it is, you can always move it. And I'll give it blue. And this one I'll give it cyan. So basically that is, I've defined the control points. So I can zoom to, I can fit to frame. I can fit to frame, where is it? I can fit to image window, and I can also fit to image to window. So therefore you can see areas that have defined the ground control points. The next thing that we are going to do is now to set resampling options. So I click on this resample. This one allows you to save the image. So I'm going to call it TM image rectif, TM image GRF. Then say okay. Now, what I'm going to do, resampling, we are going to change it to bilinear interpolation, and we can go ignore 0 in statistics. We can ignore zeros in statistics, and basically you say okay. So the process will take a few minutes. Now, once it's through, you are at liberty now to say to close the multi-point geometric correction. Now you can decide to save the model or not, but for my case, I'll say no. You can also decide to save the points or not, so I'll say no. Now, once I've done that, I will clear everything. I will close all the views. Then I'll open a new view, new 2D view. Basically, this point I have rectified my image, but I want to verify whether what I've done is accurate or not. So therefore, I need to open the initial reference image, which is TM image. Sorry. I need to open the reference image, which is basically the panchromatic. Yes. Then I open the image that I've just rectified, which is in output. Now, this is it. Now, so what you can do, you can always switch on and off and see whether it lies in the same position, or you can come to swipe. You can swipe. You can click on swipe home, then swipe, and basically you can swipe and see whether you have achieved your level of accuracy. Thank you. I believe you have seen the process of image rectification, one of ways you can do image processing. Salome.
Thank you so much, George, for that session. I believe we were all able to learn a thing or two. So I don't know if there are any questions. So yeah, I think Francis has shared a link. I believe that's for the recording. So okay, George, you can stop sharing your screen now.
Oh, sorry.
Showing us your email. Okay, thank you. So if anyone has a question, kindly over the next 5 minutes, we can have a short Q&A session. You can write the question on the chat. Oh, the link Francis shared is for your attendance. Yes, remember to register your attendance, and then so for the next 5 minutes, we're going to take questions. In case anyone has a question, you can write it on the chat. Then we'll be able to answer your question so that you can then end the session. You can also unmute your mic and ask if you have a question. Feel free. Oh, Francis, there's a concern. The attendance sheet is on view only. You can change that to enable them edit. Okay. Okay, so I'm assuming there's no question, no, but no one has written a question on the chat. So I think we can then now end. Oh, sorry. Someone asked, is the software only specific to image rectification? No, image rectification is just one form of image pre-processing, but during the PPT, George shared other types of image pre-processing procedures and processes. So they can also be done, that can also be done. And you can also do image processing itself and image analysis. So that's just, there's a lot that you can do with the software, not just image rectification. Image rectification was just for this specific class. So George, there's a question here. Someone is asking, why have you preferred bilinear as your resampling method? George, unmute yourself.
Sorry, Sally.
Yeah, it's okay.
So there are many methods of interpolation. It depends within the number of parameters. Usually, in most cases, imagery, if you are dealing with like a number, like four points, it's safe to go with the linear interpolation. If you are dealing with more than 4 points, like 9, you can go. Basically, it's just to, it's just to, and imagery, sometimes you need to a number of several points to make, it's not, therefore, that's why I went for bilinear interpolation. But even linear interpolation can do it. It's just the number of parameters that is involved in transforming the imagery. Is that one clear?
Yes, George, I think that's clear enough.
Yeah.
Yes, the one who asked the question has said it's okay. So thank you. Unless there's any other question, I believe we should be coming to an end of this. Thank you so much for attending this session. We believe we're going to be able to have more sessions in the near future. So be ready to attend. Always come on time so that you don't miss out on anything. And yeah, we are here in case of any questions. I'll leave my email with the Clement. He can share with you my email so that in case you have any questions regarding Booker services or ERDAS Imagine software or any GIS and remote software and training whatsoever, you can always reach out to me. I can always answer your questions. So thank you guys so much for attending, and see you next time, and have a lovely evening. Much welcome. You're welcome, Francis.
Thank you very much, Salome.
Yeah, you're welcome. So bye, guys.